All right, 7th graders, we're going to go through the number and operations packet and review some of the concepts that we have studied already in math. So we're going to begin with number 1 here. Taking a look at number 1, it says, which describes K on a number line. But notice that the K has these 2 straight lines on either side of it. Remember that that stands for absolute value. An absolute value of a number is a distance that a number is from 0 on the number line. And remember that if we're talking about distance, whether it be I'm running or driving a distance is always positive. So if I had like the absolute value of 7, that would simply be 7 because it's 7 units from 0 on the number line. The absolute value of -4 is going to be a positive 4 because it is 4 units from 0 on the number line. It's a distance. So what would be the absolute value of -3? If you said 3, you would be correct. Those 2 straight lines show absolute value when a number is between them. All right. Number 2, which shows the model of -3 plus 4. Well, here's a great strategy for this. First of all, what is the answer to -3 plus 4? If you said 1, you'd be correct, because remember the signs are different, so we're going to subtract them, find the difference. They cancel each other out. Now, all of these are always going to start at 0 in the number line. So if we look at which ones show it's starting at 0, meaning a point beginning at 0, it would only be A and B. And C, I guess, here. Each of them start at 0. But now we want to look at which one ends at 1, because really a number line is another way to solve the problem. And if we take a look, the only one that actually ends at the number 1 is B. And this is how it's showing it. Notice that we're going back 3, which is -3, and then we're going forward 4. So that's where that plus 4 comes in. We end at 1. 1 matches the answer. Therefore, that's the number line that describes that problem. Okay. All right, number 3 says which point is located at the opposite of -2. So take a look at these and see which one is the opposite of -2. Well, the opposite of -2 is 2, so if you said point M, you would be accurate. Number 4 has 1 divided by 17, and it says which describes n. Is it an integer, an irrational number, a rational number, or a whole number? Well, if you do 1 divided by 17 in your calculator right now, you're going to notice that it works out to be a decimal. Well, we have to decide if it is rational or not. Remember, repeating decimals and terminating decimals are rational. But here's a little trick in this. What's another way to write that division sign? If you said with a fraction bar, you'd be correct. So, is 1 divided by 17 an integer, an irrational number, a rational number, or a whole number? Well, you can write it as a fraction, and it doesn't work out to be a whole number or an integer, so that would make it rational. Number 5, again, we're looking at which numbers are rational. Rational numbers are numbers that can be written as a fraction. So right away, we know that 1 7/8 is going to be a rational number because it is written as a fraction. Whole numbers are fraction because you can simply put them over 1. So 2 is a rational number. Okay. 6.3 with the 9 repeating. Remember we talked. Repeating decimals are rational. As well, you can write them as a fraction. So now we have pi and the square root of 5. We know that pi is irrational. That's a pretty common one. I want you to put the square root of 5 in your calculator and tell me, is it rational or irrational? If you said irrational, you would be correct. For number 6 here, you're trying to solve this. So notice that we have multiplication and powers. Which comes first? The multiplication or the powers? The powers come first, so that means you need to do 2.25 squared in your calculator first, which I'm doing right here. And then after you take 2.25 squared, then you times it by 3. And if you come up with 15.1875, you would be correct. Try that on your calculator. Number 7 says, which is equivalent to 5 2/15? Remember that the fraction bar means to divide. So to convert that to a decimal, you don't even have to worry about this 5. Just bring the 5 along on the decimal. But now I want you to take 2/15 and turn it into a decimal. And when you do that, do you get A, B, C, or D? Well, the only number that repeats when you do that is the 3. So then it would be A. The line would only go over the number that repeats. Which statement is true here? To do this, you're going to have to convert them to the same form. And take a look at some of them. Well, if I look at D, I can automatically rule out D because this is telling me that a negative number is bigger than a positive number. And I know for sure that that is not true. So I start with A, and I've got 0.75. Now I have to do 0.75 squared. When I get that, I get 0.5625. Remember that I can always take a number and add zeros on it to go out the same distance, to the same place value. Is 7,500 here smaller than 5,625 10,000s? No, it is not, because 75 is going to be bigger than this 56 here. So A is not a true statement. That leaves us with B or D. Take a moment, B or C. Take a moment and decide, is your answer going to be B or C by doing a similar type of process that we just did? I was working on C, and for C I had 1.84, and then for 5/6 I got 1.83. Even though the 3 is repeating, the 0.84 is always going to be bigger. So therefore, C is the correct answer. I'm just going to double check with B because that's always a good thing to check. With B, I had 0.375 and 0.380, but they were negative. So remember that in negative, you don't want to be that far in the hole. I'd rather only be 375 in the hole than 380 in the hole. So this is the bigger one. So this was also a false statement. It's always good to just double check your work and make sure that other answers aren't true when taking a test. Right? 2 questions left. Nora is running a race that is 26.2 miles. She's running at a speed of 8 miles per hour. She has completed 3/4 of the race. How much longer will it take Nora to finish the race? Well, I have to figure out how much does she have left to run. Well, if she has ran 3/4 of it, how much does she have left to run? Well, I would take 26.2 and I want to find 1/4 of it. So I'm going to do 1/4 of 26.2. And I will find out that she has 6.55 left. But we were finding 1/4 of the 26.2 miles. So she has 6.55 or 6 55/100 miles left. Not hours, so it's not going to be D. Okay, well now I have to figure out how long would that take her. Here's where you could use some test-taking tips. If she has 6.55 miles and she's running at 8 miles per hour, is it gonna take her more than an hour or less than an hour? Well, She doesn't have 8 miles. She has less than that. So it's going to take her less than an hour, which would mean that the answer would be A. And if you actually wanted to figure that out, you could just take the 6.55 and divide it by 8. And you'd find that it's 0.82 hour, or 82 hundredths of an hour. Right. Number 10. Jeremy can plant 10 trees in 4 hours. How many trees can he plant in 10 hours? This is a great use of your proportion. So I'd like you to set up a proportion and solve. To set up that proportion, you should have put the 10 trees to 4 hours. Now, if I have 10 hours, I want to know how many trees can I get. If I use my cross products, I find out that 100 equals 4x, which means if I divide by 4, I should get 25 equals x. Okay. A little review on numbers and operations. Thank you for listening. Hope you did well. Have a great day.